Hello students, so welcome to part 8 of the lecture series where we are completing the 15 plus gate previous year questions of electronics and communication, and the topic of these videos is network theorem. So we have already completed 7 parts and this is the part 8 and this will be the last part of this section, and this lecture series is brought to you by EDAMIGO. So let's begin with the first question. So we have to find the value of RL. This is RL, so that maximum power is delivered to the load. Now, as we know that for maximum power transfer, the RL should be equal to the Thevenin resistance seen by the terminals across the load. So for this, we will first of all remove the resistance. So we will remove the resistance and mark terminal A and B across the open circuit that is being created. Now, as there is a independent voltage source, and we know that while finding the Thevenin resistance, we remove the independent voltage sources, and the independent voltage sources are short circuited. So we short circuit the independent voltage source. Now, since there is a dependent current source also, so to find RTH, we apply a V0 voltage between AB terminals and assume I0 current from the source. Okay, so let me copy the figure. Okay, so this is the figure of the question. Now we apply a V0 voltage and assume I0 current is flowing. Okay, now assume that this terminal is grounded and thus this terminal will be at voltage V0. Okay, and assume that this whole node is capital A node, and we can also see that V1 is equals to V0 by 40. So KCL at node A. Now since there is the incoming current minus 0.5 I1, so incoming current is 0.5 I1, and since it's incoming, so I've been putting a minus sign here in the equation. Okay, so here in the equation I have put a minus sign. Okay, now one outgoing current is across 20 ohm resistance, that is V0 by 20. There is one more incoming current, that is I0, so minus I0, and there is one more outgoing current, that is I1, so plus I1 is equal to 0. So from here I can see that V0 by 20 plus 0.5 I1 is equals to I0, and we know the value of I1, so it is V0 by 20 plus V0 by 80 is equals to I0, taking 80 as common, so it is 4 plus 1 equals to I0. So V0 upon I0 is equals to 80 by 5, that is 16 ohms. So A is the correct answer. Okay, now another question. So in this question we have to find the value of load R so that maximum power transfer takes place. Now since in the circuit omega equals to 10, so the impedance of the source, or I can say that if I, so we have already seen all the possible cases of maximum power transfer. So this is your voltage source and this is your ZS, and this is your RL and JXL. Now we have seen the case where RL is variable and this is constant, and we know that in such cases RL is equals to under root of RS square plus XS plus XL whole square. Now in the given question, XL is equals to 0, RS is equals to 10 ohms, and XS is equals to omega L, that is 10. So RL is under root of 100 plus 100, that is under root 200, that is under root 2 multiplied by 10. So it is 14.14 ohms is your RL for the maximum power transfer. Okay. Now let's move on to the another question. Okay. So in this question, we have given this data that when 10 volts is applied, then 2 ampere current is flowing here. And now when 20 volts is applied, what will be the current in this direction? Now, in the first question of the lecture series, we have seen the reciprocity theorem. Okay, the reciprocity theorem states that, so for proving the reciprocity theorem, I will just copy the figure. Okay, now the reciprocity theorem states that this is the input and this is the response. So we apply 10 volt input and we get 2 ampere response in direction top to bottom. So assume that this is C and D node, this is node A and B. Now reciprocity theorem states that this circuit is reciprocal, then interchanging the location of response and excitation, the ratio of response to excitation remains the same always. So in the same figure, if I interchange the location of response to excitation, so in place of 10 volt, so between C and D terminals, I will apply battery of 10 volt, and between A and B terminal, I will apply an ammeter. Okay, I will apply an ammeter. Okay, now since this circuit is reciprocal, so this 10 volt will create 2 ampere reading in the ammeter. Okay, now if I, so 10 volt will create 2 ampere reading in the ammeter. But in the question, in the second figure, that is figure B, this voltage, here voltage is minus 20 volts. So applying linearity, that is 10 volt will create 2 amperes. So minus 20 volt will create minus 4 amperes. Applying linearity, because since we know that the circuit having only resistor is always linear. So this circuit is linear, and applying linearity property, 10 volt is creating 2 ampere. So minus 20 volt will create minus 4 amperes. Okay, so according to this, answer is C. Okay, so thank you guys. This finishes the lecture series on the previous year questions on the topic of network theorems. So stay tuned and thank you.